So today I'm going to be talking about intramolecular forces versus intermolecular forces. So first we're going to be talking about intramolecular forces, and they are the forces that hold the atoms together in a compound or molecule. So there's a few things you need to know before we start, which is the duet versus octet rule, and this means an element wants to either have 2 valence electrons or 8 valence electrons in its outermost energy level to be stable and also match the nearest noble gas configuration. The next thing is electronegativity, which is just the ability of an atom to attract additional electrons, and we use electronegativity to discover the polarity by taking each electronegativity of the atoms that you're bonding together. You take the absolute values of those and subtract them to discover the polarity, which will let you know what kind of bond the atoms are creating. We are going to be talking about 4 different kinds of bonds today that use intermolecular forces, which are ionic bonds, metallic bonds, polar covalent bonds, as well as nonpolar covalent bonds. So ionic bonds are formed when electrons are transferred between 2 atoms, and this transfer happens between metals and nonmetals. So in this picture, we have sodium, a metal with only 1 valence electron, and chlorine, a nonmetal with 7 valence electrons. So what's going to happen is the sodium atom is going to give its 1 valence electron up to chlorine, so now both atoms have satisfied the octet rule, and the bond is ionic because when you check the electronegativity, it's 2.13, which is above 1.7, making it ionic. So next we're going to talk about metallic bonds, and these are formed between atoms in a pure metal or metal alloy and occur between 2 metals. So when the valence electrons of metal atoms are delocalized, this creates a sea of electrons, which is represented by the little red dots on the right, and they are surrounded by the cations they form when the electrons are delocalized. And the electrons and the cations form this crystal lattice structure, which gives metal its strength, but because of the electron sea, the cations can move around, and the mobility allows for metal to be good conductors of heat and electricity as well as malleable. So next we're going to be talking about polar covalent bonds, and these are formed when the electrons are shared unequally between 2 atoms in a compound or molecule. They also formed between 2 nonmetals. So here we have a hydrogen atom with only 1 valence electron and a chlorine atom with only 7 valence electrons. So what's going to happen is the hydrogen is going to share its 1 valence electron with the chlorine to satisfy its octet rule, and the chlorine is going to share its 7th valence electron with the hydrogen to satisfy its duet rule. So this is going to create a dipole because the electrons are going to spend more time with the chlorine since it has more of a charge, but both atoms will share the electrons. And so when you check the negativities of them, you figure out the polarity, which is 0.86, which is between 0.4 and 1.7, making it polar. So next we're going to be talking about nonpolar covalent bonds, and these bonds are formed when the electrons are shared equally between 2 atoms in a compound or molecule, and these are also formed between 2 nonmetals. So what we have here are 2 chlorine atoms, both with 7 valence electrons. So chlorine is actually diatomic, which means it's never found by itself in nature. So what's going to happen is each of the chlorine's lonely 7th electrons are going to be shared with each other to satisfy both of their octets. So when you calculate the electronegativities of them, they're both 3.66. So you subtract that and you get an absolute value of 0, and that is below 0.4, making the bond nonpolar. So next we're going to be talking about intermolecular forces, and these are the forces between molecules that hold them together. So the weaker the force is, the further the molecules are apart from each other. The stronger, the closer they are, and the even stronger the bond is when the molecules start forming those solid structures. So intermolecular forces do give properties to solids, liquids, and gases. So the properties affected by intermolecular forces are surface tension, capillary action, vapor pressure, miscibility, and boiling/melting point. So first property we're going to talk about is surface tension, or the skin over a liquid. So the amount of intermolecular force in the molecule will determine how much skin, or in other words, keeps whatever liquid contained. So as you can see, alcohol is more spread out because it has a weaker intermolecular force. Water has like a dome shape because it has a semi-strong force, and because you can see the mercury has formed like more of a solid structure because it has the strongest force of the three. So next up is miscibility, or like the mix ability, because it is how easy things mix together. So for example, if you take water and gasoline, they are not going to mix together because since like charges dissolve like charges, water is a polar substance and gasoline is nonpolar, so they are not going to mix easily. So next thing we're going to talk about is capillary action, or the movement of liquid up a tube. So if you take water, for instance, water is cohesive and adhesive, which means the molecules stick to themselves as well as other things. So when the tube gets smaller, as you can see, the water rises because the molecules are sticking to the sides of the tube more. But as you can see in the mercury is only cohesive, so it only sticks to itself. So when the tube is made thinner, the mercury stays put. So next up is boiling and melting point. So when you boil something, you're taking it from a liquid stage to a gas stage, and molecules will jump off into the gas stage, but the more intermolecular force there is, the hotter the whatever you're boiling will need to be to get the molecules to jump into that gas stage. Same thing with melting, except for with a solid to liquid, the greater the force, the harder it is for that material to become the liquid form. So next we have vapor pressure, and vapor pressure is the amount of pressure exerted by gases. So when you have liquid in a closed system and you're boiling it, it's going to create gas. And the more gas that's in the closed system, the higher the volatility is, or like the higher the vapor pressure is. So when you have a lot of liquid jumping into that vapor state, you're going to have a weaker intermolecular force, but the more difficult and the slower the liquid is jumping into that vapor state, the stronger the intermolecular force will be. So next we're going to be talking about ideal gases, which can be found with the equation PV equals nRT, and these are kind of imaginary models because there's no attraction between the molecules themselves, since there's an infinite amount of space they can be within. But then when you compare them to real gases, as molecules start to cool down into their liquid state, intermolecular forces begin to form there. So last but not least, we're going to talk about intermolecular forces within biological systems. So an enzyme is a catalyst that breaks down a molecule, but to form that enzyme, the catalyst has to react with the substrate, but they must fit together kind of like a lock and key. And the intermolecular force is what brings the lock to the key so it can react correctly. And intermolecular forces also help keep proteins together and give them their shape.